Welcome to your new unit 3B. Today's topic is creating and graphing equations in standard form. So we're going to graph in standard form and identify key parts. This will be a review. And we're going to solve for x-intercepts, which are also called roots or zeros, by factoring and using the quadratic, which is also a review. For the vocabulary, if you already have this on your cheat sheet, you don't need to rewrite it down. If you haven't filled in a cheat sheet or if you've lost it, I would write these down. We're going to be looking at parabolas, the U-shapes. Axis symmetry is that invisible line that cuts the parabola in half. Make sure we write it x equals. We're going to be using this formula, negative b over 2a. We're going to be looking at maximum minimums. This is found by using a. If a is negative, it's a max. If a is positive, it's a min. And we're also going to be focusing on x and y intercepts. And we're going to use the correct notation. If it's an x-intercept, you put the number in the x spot. If it's a y-intercept, you put the number in the y spot. We're going to do a quick review of finding key parts and graphing a parabola. You can use your cheat sheet to help you out. I'm going to start with the easy part, the y-intercept. That is just the value of c. C is 3. Make sure you write it as a y-intercept, putting in the y spot. Next, I'm going to do the axis of symmetry. We're going to use that formula, x equals negative b over 2a. Plugging in, b is 4, so negative 4 over 2 times a is negative 2. Negative divided by negative is going to switch us to a positive 1. Because we have the axis symmetry, we also have half of the vertex. We have the x value. To find the y value for anything, you can just plug in. So I'm going to go back to my original equation, y equals, and every x I'm going to plug in a positive 1. Quick evaluating, 1 squared is 1 times negative 2, negative 2. 4 times 1. If we combine all these values, we get y is 5. We can plot the points we have. We have the vertex at 1, 5, so 1, 2, 3, 4, 5. We also have a y-intercept at 0, 3. And because we have an axis symmetry at x equals 1, we can do its symmetrical point at 2, 3. We still need 2 more points. You can use the table function on your graphing calculator to find the additional points. One of them is at 3, negative 3, and at negative 1, negative 3. Then we're going to draw the parabola u naught v. Example 2, we're going to find the same things, but we're also going to add in finding the x-intercepts. Start with the basic ones. Y-intercept, same thing. It's the value of c, so 0, 8. Axis of symmetry, that's x equals negative b over 2a. That gives me negative 8 over 2 times 2. So my axis of symmetry is x equals negative 2. Vertex, we have the x value. To find the y value, plug in negative 2. You can use your calculator or you can do it out by hand. What you end up finding is 0. So that's everything we've been doing for a while. The new part is finding the x-intercepts. And we can do this 2 ways. We can either take the equation and factor it, or we can use the quadratic formula. You can use either method and it will both get you the correct answer. I like to look and see which way seems easier. Look and see if this equation looks like it could be factored easily. Now, a is greater than 1. However, it is also a greatest common factor, meaning I can factor out a 2 from all the parts. If I factor out a 2 from all the parts, I'm left with 2 times x squared plus 4x plus 4. Now that looks a lot easier to factor since a is now 1. I can use the x method, times to get a 4, the last term, and add to get a 4, the middle term. Well, the two numbers that work are 2 and 2. So factored, this is x plus 2, x plus 2. As a reminder about how to solve, you set each factor to 0 and solve. Minus 2, minus 2. I get the same answer for both of them, where x equals negative 2. Since I only have one answer, that means I only have one x-intercept. We're going to write it as an x-intercept, making sure you write it as an ordered pair with the value in the x spot. Now we need to graph this. You can use your graphing calculator to plot 5 points using the table. Now, this time, my vertex and axis symmetry are the same point at negative 2, 0. That's the only point I have, so I really need to use the table function to get more points. If I do so, I have a couple more points I can add. I have negative 3, 2, and its symmetrical point, negative 1, 2. Then I have the y-intercept, 0, 8, 1, 2, 3, 4, 5, 6, 7, 8, which is just off of my graph, and its symmetrical point, negative 4, 8. So we're combining everything we've been learning about quadratics and factoring. We're now going to be using the quadratic formula. In case you've forgotten it, negative b plus or minus square root of b squared minus 4ac all over 2a. Example 3, we're going to find all the same things. I want you to pause the video and see if you can find the y-intercept, axis symmetry, and vertex on your own. All right, let's check and see if you got these correct. Y-intercept, 0, 5. Axis of symmetry, x equals negative b over 2a. So that became a positive 11 over 2 times 2, which leaves me with 11/4, or if you wrote it as a decimal, 2.75. So vertex, we already have half of it, 2.75, or 11/4. If you plug it in, and you can use your calculator to plug it in, you end up with a y value of negative 10.125. Now for the x-intercept. If we look at the equation, 2 is and it's not a greatest common factor. If I wanted to factor this, I could go through and do a times c and create grouping. However, that's a longer factoring process, so instead I am going to use the quadratic formula. As another reminder, it's negative b plus or minus square root of b squared minus 4ac all over 2a. We're going to start slow and just plug everything in. Negative b, which switches to become a positive 11, plus or minus square root of b squared, negative 11 squared, minus 4 times a times c all over 2a. All right, let's start simplifying. Inside of the radical, this is the discriminant. We're going to simplify negative 11 squared. Negative 11 squared is going to switch and become a positive 121. And then we have a negative 4 times 2 times 5, so it's going to stay negative. 4 times 2 times 5 is 40. That leaves me with a discriminant of 81. So what we're at now is we have 11 plus or minus 81 square root over 4. We like 81 because it is a perfect square, so we end up with 11 plus or minus 9 square root of 81 divided by 4. Work through your two options. 11 plus 9 is 20, divided by 4 is 5. 11 minus 9 is 2, over 4 is 1/2, or 0.5. So we do have two x-intercepts this time. We're going to make sure we write them as x-intercepts. Ordered pair. So my first x-intercept is 5, 0. My second intercept is 1/2, 0. We can use our graphing calculator to plot all the points that we have. I'm going to start with my vertex, which is at 2.75, so just about 3, and at negative 10.125, so that's just a little bit below negative 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm going to be going off my graph a little bit here. I have a y-intercept at 0, 5. I have my two x-intercepts, one at 5, 0, and one at 1/2, 0. So here's the 1/2, 0, 5, 0. I really just need one more point, and I can do the symmetrical point of the y-intercept. The symmetrical point to the y-intercept is going to be, over symmetrical at 5.5 and up 5 about there. And I can draw my parabola. Ooh, not too good of a looking parabola this time. If you still need more help, come in for help on Monday, Wednesday, Friday mornings or after school till 3 o'clock, or watch the additional videos on the page.